Hello students, welcome to Shri classes. Let us start lecture number 5, polynomials. We'll understand today what is division algorithm. So division algorithm is defined something like this. If p of x and g of x are two polynomials, with g of x not equal to 0, then we can find q of x and r of x such that q of x and r of x such that p of x equals g of x into q of x plus r of x, and this is called division algorithm. This result is called division algorithm. With the condition where r of x equals 0 or degree of r of x should be less than degree of g of x. The degree of r of x should be less than the degree of g of x. So this is the division algorithm. Here, what is the meaning of this division algorithm? Once again, I will write over here. The meaning of this result, division algorithm, is dividend equals divisor into quotient plus remainder. Divisor into quotient plus remainder. I hope you are able to understand. So this is a division algorithm, and we will solve some numericals in with respect to division algorithm. Let us take up some numericals. So I'll take up from NCERT numericals today. Many numericals will be from NCERT textbook. Okay. So let me take one example as second example. I'll erase this. You have to note it down. Pause the video to note down. One question is there from textbook. Divide, this is the question. I will erase all this thing, division algorithm also, because we are anyway solving the numericals on division algorithm. Question goes like this. Example number 6 it is. Example number 6 of your textbook. Divide two x square plus 3x plus 1 by x plus 2 and verify the division algorithm. Verify the division algorithm. We have to divide this one and verify the division algorithm. Solution. Let p of x equals 2x square plus 3x plus 1 and g of x equals x plus 2. Now dividing p of x by g of x, we get dividing p of x by g of x. What is that we get? We will go for a long division process here. So I use the long division process over here. This is 2x square plus 3x plus 1 and x plus 2. X plus 2 is the divisor here. So let us divide this one by long division process. Couple of important steps to be noted down. This polynomial, when you write in the place of dividend, ensure that the powers are in the descending order. Similarly, the powers of the variables are in the descending order in g of x also, divisor also. Suppose a power is missing, x cube plus x it is. So x square if it is missing, add 0 as a coefficient and introduce that term. But ensure that all the powers will be there in a particular polynomial. For example, if the maximum power is 4, then x to the power 4, x cube, x square and x and then the constant term. This is the sequence that we need to follow. If some of these terms with certain power are missing, introduce 0 coefficient and that power. I hope you are understanding. So now let us how to divide this is important is I use the 9th standard method, which is a foolproof method, rather it is a stupid proof method. That is to find out the terms of the quotient. What should be the terms of the quotient over here? That I will do by 9th standard method. First term divided by the first term. First term of the quotient is 2x square divided by x here, which is 2x. So 2x, x into x, 2x square, 2 into 2, 4x. Yeah, it is right. And 2 into 2, 4x plus 4x. So minus this will cancel because we have to subtract it. This is minus x, pull it down, plus 1. Now see here the degree is 1, here also the degree is 1. How long this division process continues? This division process continues till the remainder becomes 0 or the degree of the remainder should be less than the degree of the divisor here. What is the divisor? Degree is 1. Here also it is degree is 1 and therefore the still it will continue. That means the division process will continue. But therefore what I am saying is how long this division process will continue? As long as the degree of the remainder is less than the degree of the divisor or the remainder should be 0 here. Okay. So next. So here second term of the quotient. What is the second term? Minus x, first term divided by first term, x minus 1. So this is minus 1. So x into minus plus 2 into minus 1 minus 2, which equals plus this will cancel and this is 3 over here. Anything else? Therefore the remainder is 3 here. Therefore here I'll write here p of x equals 2x square plus 3x plus 1, g of x equals x plus 2 and q of x is nothing but the quotient here. This term is called q of x, which is the quotient here, which is 2x minus 1 and finally this remainder here is r of x. So r of x equals 3 here. Now to verify the division algorithm, how to verify the division algorithm? This is what we have found out. We found that the remainder is 3 here. Now to verify the division algorithm, how do you verify it? You take the RHS and prove the LHS. The RHS, what is the division algorithm, this thing? What is the division algorithm? P of x is equal to g of x into q of x plus r of x. You take the RHS over here and arrive at LHS. That means you find out g of x into q of x plus r of x and check whether you get the p of x or not. And that is the verification. Okay. So let me write here now. To verify the division algorithm, g of x into q of x plus r of x equals, what is g of x? X plus 2. into q of x. Here I have written 2x minus 1 plus r of x 3 here, which equals x into 2x minus 1 plus 2 into 2x minus 1 plus 3, which equals 2x square minus x plus 4x minus 2 plus 3, which equals 2x square minus x plus 4x plus 3x minus 2 plus 3 plus 1. Isn't it? This is what we are getting. And this is equal to p of x equals dividend. Hence, or I write therefore g of x into q of x plus r of x equals p of x. Hence, verified. See, you have got p of x or not? 2x square plus 3x plus 1, 2x square plus 3x plus 1, and hence verified. So I'll take up the next question. Now let me take one more example. Example number 8 of your textbook. Here the question is p of x equals 3x square minus x cube minus 3x plus 5, and divisor is given. Divide p of x by g of x and verify the division algorithm. This is the given question. We have to divide the p of x by g of x and verify the division algorithm. Let us find out. Already given here, p of x is given, g of x is given, but let me write in a particular order because that is most important, the decreasing order of the power. Therefore, let us write p of x in the decreasing order of the power of the variables, which is minus x cube plus 3x square minus 3x plus 5, and g of x also let us write in the decreasing order, minus x square plus x minus 1. So applying the division algorithm, let us divide this now. This is minus x cube plus 3x square minus 3x plus 5. Here we will write the quotient, and this is minus x square plus x minus 1. So here I will work out the terms of the quotient. First term of the quotient, first term divided by first term, minus x cube divided by minus x square, which is x. So x here, x into x square minus x cube plus x square minus x, change the sign, minus x cube plus x cube cancels, 3x square minus x square 2x square minus 3x plus x minus 2x, pull down 5. Next term, 2x square divided by minus x square, which is minus 2, minus 2, minus into minus plus 2x square, plus into minus minus 2x, minus into minus plus 2, change the sign, minus, this will cancel and this also will cancel, plus 5 minus 2 plus 3. So the remainder is plus 3 over here. Let me check. Yeah, it is correct. X minus 2 is the quotient. So to verify the division algorithm, let me write here p of x already written, g of x I have written. Therefore q of x is equal to here, what is the quotient? X minus 2, and r of x is plus 3 here. Is it right? Okay, so let us verify the division algorithm and see. To verify the division algorithm, I write to verify division algorithm. To verify the division algorithm, g of x into q of x plus r of x equals, what is g of x? Minus x square plus x minus 1 into q of x, x minus 2 plus r of x 3, which equals this into this, minus x cube minus of minus 2x square plus x into this plus x square, x into minus 2 minus 2x minus 1 into x minus x minus of minus plus 1 into 2 2 plus 3. So this will be minus x cube plus 3x square minus 3x plus 5. Is it p of x minus x cube plus 3x square minus 3x plus 5, which equals p of x, which is dividend. Okay, so hence division algorithm verified. Hence division algorithm verified. I hope you have understood, and please note it down. Here we have a typical sum once again, and see here, if p of x equals 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2, and if root 2 and minus 2 minus root 2 are the two zeros, then find all the zeros. Here we have to find all the zeros. Two zeros are given and find all the zeros. What do you mean by all the zeros? How many zeros will be there? So look at the quadratic polynomial. This is of degree 4, so therefore it can have maximum 4 zeros. 2 zeros have been given, another 2 zeros are to be found out. So with the 2 zeros, we have to form a quadratic polynomial and divide the given p of x by quadratic polynomial, and being it is biquadratic, the quotient also will be in a biquadratic. Split the middle term to find another 2 zeros. So let us try to find out this one. First let me find out the quadratic polynomial which becomes a divisor. So how to find out a quadratic polynomial that becomes the divisor, we will see first. So solution, okay, root 2 is x equals, see here, root 2 is a 0 here, isn't it? Root 2 and minus root 2 are zeros. Root 2 and minus root 2 are zeros, implies x equals root 2 implies x minus root 2 equals 0, x equals minus root 2 implies x plus root 2 equals zeros. What are the roots here? The values of x, if substituted, the given polynomial reduces to 0, isn't it? So the roots are nothing but x is equal to, or I can also directly say x minus root 2 is a factor of the given polynomial into x plus root 2 is a factor of a given polynomial. If I subject it to 0, then I'll get a quadratic polynomial. It's a quadratic equation. I'll get 0, I'll eliminate. So if you multiply these two, you are going to get a quadratic polynomial which you have to divide that. Okay, so that also you can do it. So now what I am doing here is x is equal to this. So these two are 0 now, isn't it? Therefore there implies x minus root 2 into x plus root 2 equals 0. I can do this also. Now this is x square minus root 2 the whole square equals 0, implies x square minus 2 equals 0, implies x square minus 2 is a factor of p of x. Did you understand here? X square minus 2 is a factor of p of x. See, here you need not equate it to 0. Why I equated to 0 here is, I took x is equal to root 2 is one value of the root and x equals minus root 2 is another value. So if you transpose this side, you get x minus root 2 and x plus root 2. Directly without 0 also you can take here, because ultimately we are going to find a quadratic polynomial, and that quadratic polynomial should divide this one, isn't it? X square minus 2 here is a factor of p of x. Therefore let g of x equals x square minus 2. Now let us divide the given biquadratic polynomial. So dividing the polynomial, here it is x square minus 2, let me put this side, 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2. Here x square minus 2, g of x is x square minus 2. So we have formed a quadratic polynomial which is a factor of that one. First we will divide the biquadratic by that factor which is a quadratic polynomial. I am going to get a quadratic as a quotient. Quotient also will be a quadratic polynomial. Split the middle term to get another roots. So here, what is the first term here? The first term I will work out here somewhere rough here. First term 2x to the power 4, 2x to the power 4, or just a moment, I will work out here. Rough work. What is that? 2x to the power 4 divided by x square, which is equal to 2x square. So first term of the quotient is 2x square. So this will be 2x to the power 4 and minus 2 into 2, 4x square, minus 4x square, minus 4x square. What about here? Plus, you can add 0x cube or simply 0 you can keep it here. And now change the signs here, minus, minus, plus. This will cancel, minus 3x cube as it is. Okay, and minus 3x square plus 4x square plus x square, pull down, plus 6x. Now, first term of the quotient minus the second term of the quotient, minus 3x cube divided by x square minus 3x. X square cancels, minus 3x. So minus 3x. So x square into minus 3x, minus 3x cube, minus 2 into minus of minus plus 2 into 3, 6x, 0, plus here, minus here, minus here. So this will cancel, this will become x square, plus 6x minus x cancels, pull down 2, which is minus 2 here. Is it right? Okay, next, x square divided by x square, which is 1, plus 1, x square into plus 1, x square, minus 2 into plus 1, minus 2, change the sign, this will cancel, 0, 0, and therefore we have got the remainder as 0. Here quotient is equal to, therefore q of x equals 2x square minus 3x plus 1. To find zeros, let q of x equals 0 implies 2x square minus 3x plus 1 equals 0. Split the middle term, 2 into 1, 2, and here I should get minus 3, which is nothing but 2 into 1, minus 2, minus 1. So 2x square minus 2x minus x plus 1 equals 0 implies common here, 2x, x minus 1, minus common or minus 1 common you can take, x minus 1 equals 0. So x minus 1, 2x minus 1 equals 0, x minus 1 equals 0, 2x minus 1 equals 0 implies x equals plus 1 and implies x equals minus plus 1 by 2 here, isn't it? So finally we got 4 zeros. Which are the 4 zeros here? X is equal to 1, x is equal to half, x is equal to root 2 and x is equal to minus root 2. These are the 4 zeros. So finally I'll write here, therefore the zeros are in this, therefore zeros are, all the zeros are root 2, minus root 2 then 1 and half. This is the final answer. Let me check the answer. Yeah, so we have root 2 minus root 2 and 1 and half. These are the zeros. So this is how we can find out the zeros of a given polynomial by adopting the division algorithm. Here the division algorithm is most important. While solving these numericals, make sure that you do it very systematically and very patiently. And many times I calculate this terms of the quotient by dividing the first term by first term, which is given in your 9th standard, and actually speaking that is the best method. In a hurry, especially during exams, mind will be under very high stress, and sometimes the mechanical methods will be able to yield the good results. So here mechanically we are doing without any mistakes, and I request all of you to follow to find out the terms of quotient by dividing the first term of the dividend by the first term of the quotient. Get the terms of the quotient perfectly and then proceed with the division algorithm. So note it down. I'll take up the next sum now. Here we have one more typical sum, and given polynomial is this, g of x is then g of x is given as x square plus 1 minus x. Question asked over here is divide p of x by g of x and find out the quotient and remainder. What is the question asked? Find out the quotient and remainder over here. So let us try to find out the quotient and remainder. Okay, so here it is a p of x is very typical. It is 4, cube is missing here. For x to the power 4 is there, x cube is missing over here, and therefore in order to facilitate the division process, I'll introduce the cubic x cube with a 0 coefficient. If it is multiplied by 0, then the net result will be a 0. It will not affect the given polynomial as such. So let me write once again the polynomial. What is the question asked here? We have to find out find q of x and r of x, quotient and remainder. Solution. First let me write p of x. P of x is equal to x to the power 4 plus 0 x cube minus 3x square plus 4x plus 5. I have introduced 0 x cube here because cube is missing, and g of x is equal to x square minus x plus 1. In the decreasing order I'll write it, decreasing order of the power, x square minus x plus 1. So let us apply the division algorithm over here and see what is that we are going to get. This will be x to the power 4 plus 0 x cube minus 3x square plus 4x plus 5, and here it is x square minus x plus 1. Terms of the quotient I am working out separately. X to the power 4 by x square, x to the power 4 divided by x square is x square. The first term of the quotient is x square, therefore this will be x to the power 4 minus x cube and 1 into x square plus 1 into plus x square. Change the sign, minus plus minus, this will cancel. 0 x cube plus x cube, this is plus x cube minus 3x square minus x square minus 4x square plus 4x. I am pulling it down. Next term of the quotient, x cube divided by x square, which is x, so plus x, x cube, x into this, minus x square plus x. Change the sign, minus plus minus, this will cancel. Minus 4x square plus x square minus 3x square plus 4x minus x plus 3x. Next, minus 3x square divided by x square, which is minus 3, so minus 3 into x square is minus 3x square minus x minus 3 plus 3x, okay, and plus 1 minus 3, minus 3. Let me pull down here itself, plus 5. It is correct? Now, change the sign, plus, minus, plus. So, this will cancel, plus 5, plus 3, plus 8. And therefore, our answer to this question, q of x, therefore, answer is q of x equals x square plus x minus 3, and r of x remainder is 8. What type of polynomial is r of x here? Do you understand? Is it not a constant polynomial? Yes, it is a constant polynomial. So, let me check the answer for this. This is exercise 2.3, first one, second one. First and second. X square plus x minus 3 and 8 is the remainder. It is correct. So, note it down. I will take up the next question. First, note it down. Here we have one more sum. Exercise 2.3, third one. If x is given to you, if two zeros are so and so, find all the zeros. It's all zeros means how many zeros will be there? This is a biquadratic polynomial, degree is 4, therefore maximum 4 zeros will be there. 2 are given, another 2 we need to find out. That is the question asked. So let's see here, solution. Solution. Roots are, which are the roots given here? X equals root of 5 by 3 implies x equals root 5 by root 3 implies x minus root 5 by root 3 equals 0 implies root 3x minus root 5 equals 0, because this root 3 goes this side, or I'll write that also. Root 3x minus root 5 by root 3 equals 0 implies root 3x minus root 5 equals 0. Similarly, given root is x equals minus root 5 by root 3. So, here implies x plus root 5 by root 3 equals 0. Root 3x plus root 5 by root 3 equals 0 implies root 3x plus root 5 equals 0. Therefore, root 3x minus root 5 and root 3x plus root 5 are factors of p of x, fx it is given, f of x. Okay. Therefore, root 3x minus root 5 into root 3x plus root 5 is a factor, implies, multiply this one, root 3x into root 3x, root 3 into plus root 5, or I'll do the one thing, implies root 3x into root 3x plus root 5 minus root 5 into bracket root 3x plus root 5. This implies root 3 into root 3, 3x square, this into this, root 15x minus root 15x minus 5. Is it right? Which implies this will cancel, 3x square minus 5 is a factor of f of x. Therefore, let g of x equals 3x square minus 5 here. You got it? We have got 3x, g of x is equal to 3x square minus 5. 3x square minus 5. Let me check it. Yeah, this is third one, no? Yeah, third one. 3x square minus 5 is g of x. We have to carry out the division algorithm. I have to divide this by this now. Okay. So, I will do this sum here. Division algorithm. What is that one now? P of x is 3x to the power 4, 3x to the power 4 plus 6x cube minus 2x square minus 10x plus minus 5, and we have to divide this by g of x is 3x square minus 5, and I will work out here, this is a rough space here, to work out the terms of the quotient. Rough space. What is the first term of the quotient? 3x to the power 4 divided by 3x square, which is equal to x square. So x square 3x to the power 4 minus 5x square. Where should write? Below this one. Like term should be written one below the other. Therefore plus 0 I will introduce, and therefore minus 5x square here. Minus 5x square. You understood? Here it is a 0 because this term is missing here. 3x to the power 4 minus 5x square it is. So I have introduced 0. Change the signs. Minus, minus, plus. This will cancel. This will become 6x cube and plus 3x square. Pull down. Next is minus 10x. Second term of the quotient 6x cube divided by 3x square, which is equal to 2x. So plus 2x. So this will be, it is plus 2x. This will be 6x cube minus 5 into 2 10x minus 10x plus 0 I will introduce. So change the sign, minus here, plus here. So this will cancel. This is 3x square minus 10x plus 10x will cancel. This will be 0 here, and let me pull down here. This is minus 5. Is it not? Minus 5, I am pulling it down. Third term of the quotient 3x square divided by 3x square, which equals 1 plus 1. So 3x square minus 5 plus 1 into minus of plus minus 5 into 1 5. Change the sign, minus here, plus here. So this will be 0, this will be 0. So the quotient what we have got here is, I write here, okay, quotient q of x equals x square plus 2x plus 1. In order to find out the zeros, I have to subject the quotient to 0 here, and therefore let this be equal to 0, implies x square plus 2x plus 1 equals 0. So how do you find out now? It is 2x here, and 1 into 1 here I should get plus 1, and let me check whether the quotient is correct. Then I'll x square plus 2x plus 1, it is correct. So let's see, here I require 1, and this here I should be 2 here. 1 into 1 implies x square plus x plus 1 equals 0. Take common here, x plus 1 plus x plus 1 equals 0, implies x plus 1 into x plus 1 equals 0, implies x plus 1 equals 0, x plus 1 equals 0, and therefore I'll write here, implies x equals minus 1 and x equals minus 1. Is it right? And therefore finally my answer, I'll write here, therefore zeros are where are the zeros? Find out which are the zeros here. Finally we have root of 5 by 3 minus root of 5 by 3 minus 1 and minus 1. All the zeros you have to write here. you cannot say that, just because you have got both the values as -1, you cannot say that it is only -1. I mean, only once you cannot write, because we have to have a 4 zeros over here. All the 4 zeros are alpha, beta, gamma, delta. If these are the 4 zeros, then definitely all the 4 zeros need to be mentioned, because only in that case, if you multiply the factors, you'll be able to get the biquadratic. For example, this is x minus this into x plus this into x plus this into x plus this. If you multiply all this, you'll be able to get the p of x here, isn't it? So this is one of the good problems. And important thing here, by equating to 0, I am eliminating the denominator over here. Otherwise, you are going to face a lot of problem. And whenever if you get the denominator as a constant for your entire quadratic polynomial, that should be taken out by LCM or by common. I don't know whether you are able to understand. See, I am eliminating the denominator part over here. My quotient, the divisor is not containing the denominator part. If you get a denominator part over here, you have a really big trouble. And in order to avoid that, this is the only way which I can avoid. What is that? So what I did, I subjected to 0 over here. X equals, this is one root, and x equals, this is also root. By transposing towards the left side, I am able to eliminate the denominator portion. Otherwise, you will have really big trouble. I don't know whether you can understand. You have to practice these questions a lot. Okay, so let me take the next question. First, you note it down. Let me take another question. Let us have a look at some optional numericals. Optional exercise 2.4. In that, given is a p of x and g of x is x square minus 2x plus k. If the remainder is x plus a, find the value of k and a. So as it is, I have to consider g of x here, including that constant term, and also the p of x as it is, and apply the division algorithm, divide and find out the remainder, equate the remainder to x plus a. And on comparing the coefficients, we should be able to find out the value of k and a. So remember, we should be able to find out the values of k and a on comparing the actual remainder that we get with x plus a. Okay, that is the key point over here. You must remember that. Okay, so let me apply the division algorithm directly. So 4, 3, 2, 1, 0. So I'll apply the division algorithm. This is x square minus 2x plus k. I'll write a little bit this side. Okay, x to the power 4 minus 6x cube plus 16x square minus 25x plus 10. And here we'll get the quotient. G of x is x square minus 2x plus k. Terms of the quotient, I'll work out in the rough here. The terms of the quotient, without the terms of the quotient, I'll never work. X to the power 4 divided by x square, which is x square. So first term x square, x to the power 4 minus 2x cube plus kx square plus kx square minus plus minus, this will cancel, minus 6x cube plus 2x cube minus 4x cube plus 16, this one, here it is, plus 16x square minus kx square. So can I write like this, 16x square minus kx square. So what is common here, x square, 16 minus k x square. Can I write like this? I'll write this as a coefficient there. So plus 16 minus k x square. Okay, now pull down this 25x minus 25x will pull down. Now second term, 4 minus 4x cube divided by x square, which equals minus 4x. It is minus 4x. Minus 4x. So now minus 4x cube minus 2x minus of minus plus 8x square plus 8x square plus k into minus 4x minus 4kx minus 4kx. Let us work out plus minus plus x to the power 4. This is minus 4x minus 4x cube plus 8x square minus 4kx. It is correct. Okay, now this will cancel, minus 4x cube plus 4x cube, and here this is 16 minus k minus 8. 16 minus k x square minus 8x square is nothing but 16 minus k minus 8 into x square implies 16 minus 8, 8. 8 minus k into x square. So I am writing like this here. Are you able to understand? 16 minus k x square minus 8x square, 16 minus k minus 8 into x square, 16 minus 8 is 8, 8 minus k x square. So for this I am writing 8 minus k into x square, and here minus 25x plus 4kx. What is common here? X common. Minus 25 plus 4k times x I will write. So what is that I am going to write here? Minus, this is minus 25 plus 4k. Just a moment. Minus 25x plus 4kx, or I can write 4kx minus 25x, and therefore x is a common, 4k minus 25 I will write here. So this is plus 4k minus 25, both are same here and here, into x. I am erasing that. Okay, now you pull down the constant here, plus 10. Next, 8 minus k x square divided by x square, which I'll get 8 minus k. So plus 8 minus k. Check now. 8 minus k x square minus 2x into 8 minus k minus 2x into 8 minus k. 2x into 8 minus k here. Okay, plus k into 8 minus k. 8 minus k. This is what I am getting, isn't it? Now I have to modify this a little bit, and what I have to do here is take 2 inside and make x outside here. Are you able to understand? That way I'll try to simplify it. So let's see here what I can do here is, I hope you are able to understand. This is minus x, 2 goes inside into bracket, 2 into 8 16, and 2 into this minus 2k x. This is what I am going to write it here. Are you able to understand? So minus remains as it is outside, only 2 I am taking, 16, and it is 2k. Minus remains outside with x as a coefficient. This has a coefficient of x here. So I'll write this as 16 minus 2k times x. Even a little more modification also I can do, but let it be there as it is. Let me check. If something is required, I will further modify. and this is 10 plus k into 8 minus k. Let it be there as it is. Okay, so let us see what happens here. Minus, plus, minus. This will cancel. Now this I will work out separately in a rough. That is 4k minus 25x, and this plus here plus 16 minus 2k times x. I am working out what is common here. X is a common, so 4k minus 25 plus 16 minus 2k times x. What is this one? 4k minus 2k, 2k minus 25 plus 16 minus 9. So this will be here, what I am writing is plus 2k minus 9 into x, and this will be 10 minus k into 8 minus k here, which is 10 minus 8k plus k square, or k square minus 8k plus 10 is the last term here. So I'll write here plus k square minus 8k plus 10. So finally I have got this as a remainder here. This is the remainder over here. Okay, this one I would like to compare now. So what is this remainder is equal to? R of x is equal to x plus a, given x plus a. So what is our R of x here? 2k minus 1, 9, 2k minus 9 times x, okay, plus k square minus 8k plus 10, plus k square minus 8k plus 10 equals x plus a here. What is the value of x and k now? Therefore, on comparing the coefficient of x with the coefficient of x here, 2k minus 9 equals 1. On comparing, I'll write here, on comparing coefficients and constants, we get 2k minus 9 equals 1, implies k equals 9 plus 1, this comes here 10 to 5, here we get k equals 5. Okay, and what is a here? A equals k square minus 8k plus 10, which equals, fill up the value of 5 here, 25 minus 40 plus 10, which equals 25 plus 10, 35, 35 minus 40 minus 5. So we are getting finally the answer for this question is k equals 5, a equals minus 5. This is what we are getting here. Let me check the answer here. Yeah, k equals 5, a equals minus 5. So I hope you are able to understand this question, and with this I think I have covered almost many sums here. How to solve those things I have indicated, and many numericals I have taken from R.D. Sharma as well as your textbook. All these sums are from your textbook basically. The optional numericals are very important. I have solved few optional numericals in this already in my previous session also, and I request you to solve further. Okay, and you have to get back to me if you have any doubts. Okay, so here we are going to end the lecture on polynomials. If you have any difficulties, then please get back to me, and meantime you can note it down, and then we'll see you in the next lecture. Thank you very much.